For this presentation, there is three sections. The first one is about the equations of residential sector. The second one is about the structure of the residential sector in MAED. And the third part will be about the input data for the residential sector. The energy demand of the residential sector is calculated, taking into account the following aspects: the living conditions of the population, place of residence, urban and rural areas, types of residence, different types of houses or dwellings, representation of the lifestyle of individuals, equipment rates, time of use, thermal comfort, for example. And when the demand for an end use can be met from different sources for energy, the values are calculated in terms of useful energy. This is what we have seen before in the industrial sector with my colleague Sofiane Wednesday. The final energy demand for those end use is then calculated from energy efficiency and the share of the different energy forms. It's always the same methodology when we deal with an energy use which is provided from different sources. So in MAED, there is a typical structure that is defined in MAED, and for the residential sector, the predefined subsectors are urban houses and rural houses, and there is 5 main uses of energy: home appliances and lighting, air conditioning, cooking, water heating, and space heating. The energy forms that are used for home appliances and lighting are electricity and fossil fuels. For air conditioning is the same. We use electricity and fossil fuels. And for cooking, we use electricity, fossil fuels, traditional fuels, solar, thermal, and modern biomass. And all the forms of energy that is shown here are in competition to provide energy for water heating and space heating. So the first parameter is used to calculate the energy demand for the residential sector is the number of houses. And it is calculated for each type of houses. And to have this number of dwellings for each type of houses, we have 3 parameters: the percentage of population in the urban area, the average number of people per dwelling in urban areas, and the average number of people per dwelling in rural areas. Remember that the population is given in the first table that we have seen in the first presentation, the table related to the demography. There we will introduce the total population in the country. So the number of urban dwellings will be calculated by multiplying the total population by the fraction of or the part of the urban population, and it is divided by the number of people per dwelling in the urban area. The percentage of rural population is 100 minus the percentage of 100 minus the percentage of urban population. And in the same way, we can calculate the number of rural dwellings. So the number of rural dwellings is calculated by multiplying the total population by the fraction of rural dwellings, which is in this part, and this is divided by the number of people per dwelling in rural areas. This is the first parameter to calculate is the number of houses of each type of houses. Then the equations used to calculate the different demands. That's a remark. The equations used to calculate the different demands of the urban and rural sectors are the same, and therefore, to simplify the presentation, we will just use dwelling instead of urban and rural dwellings. This is this. We will use the same equations for the different types of households. For the following uses, the model first calculates the useful energy, cooking for the use cooking, water heating, space heating, air conditioning, and this is calculated. Sorry, there's I think there's a word that is missed. It's given by a dwelling. This useful energy is given by a dwelling, and for the mistake. I think that is a mistake here. For sorry here for uh, for 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 cooking, water, space heating, and air conditioning, the useful energy is calculated per dwelling. And for water heating, sorry, the useful energy is calculated according to the per person. The specific requirement is given per person. So we start by the water heating. So as I mentioned, that the water heating, the useful energy for water heating is calculated per person. So the useful energy demand is given by the multiplication of the number of houses multiplied by the people per dwelling multiplied by the percentage of homes with water heating systems multiplied by the specific consumption of hot water per person. For the other uses, the specific consumption is given by a dwelling. It's not per person. This is what we will see here. And for cooking, the useful energy demand for cooking is the multiplication of the number of households by the specific energy consumption per household. For air conditioning, the specific requirements will be different from one type of houses to another. And the equipment rate will be different from one type of houses to another. So the useful energy demand is given by multiplying the number of households by the percentage of houses with air conditioning by the specific requirements. This is the energy consumed by household for per year. This is given for each type of houses, and the total useful energy demand will be after it's the aggregation. It will be the sum of all the useful energy demand for all the types of houses. For heating, we'll need several parameters. For the different types of households, we will need the average size, the percentage of homes that need heating, the floor area that is heated, and the specific heat losses of each type of dwelling, which is a parameter that indicates the energy performance of the dwelling or the insulations of the household, of the dwelling, sorry. How is the insulation of the dwelling? In general, heating is only needed during the winter season, and we will need another parameter, that's a factor that is called degree day, which represents this season behavior. We will see the definition of this factor after, and also how to calculate the heat losses rate or how to estimate it. We'll see this in the next slides. So the equation of the heating is the useful energy demand for heating for each type of houses is calculated by multiplying the number of houses by the percent of houses with heat and with heating, sorry, and this is multiplied by the average house size, multiplied by the fraction of area that is heated, multiplied by the heat losses factor, multiplied by the degree day coefficient, and this is multiplied by 24 hours. And the total useful energy demand for all the houses will be the aggregation of the useful demand for different types of houses. So here is the definition of the degree days. So degree days are calculated for the in general in winter for the season, the winter season, and when we need heating, and in the winter months, the degree day is the difference between a reference temperature, which is, for example, 18 degree Celsius, minus the monthly average temperature multiplied by the number of days per month. This is evaluate how many degree days uh, uh, that evaluate the need of heating in the month, and for the whole year we will aggregate this need for all the months of the year, and typically it will be for the months of winter. So it's the same. What it's like what we have seen for the industrial sector. So when we have, we will deal with uses and uses that are that where the energy is provided from different energy sources that are in competition. We use the useful energy, and to go from the useful energy to the final energy, we we use the two parameters: the penetration rate and the efficiency of the different forms of energy. So, for example, if we have here, for example, the one when we need 100% of heat for cooking, this is, for example, will be provide 30% from fossil fuels and 70% from electricity. So these are the penetrations rates, 30% and 70%. And if we have that the information about the efficiency, we can estimate the final demand for each form of energy by multiplying the useful energy by the penetration rate and dividing this by the efficiency of the energy form. And this is how to calculate the final demand for each form, for each energy form. To continue with how to calculate the demand for heating, just I will present a definition of district heating for those who are not familiar with this technology. District heating is an underground infrastructure asset where thermal energy is provided to multiple buildings from a central energy plant or plants. Steam or hot water produced at the plant is transmitted 24 hours, 7 days through highly insulated underground thermal piping networks. We will see we can find in the energy balance an element, an item, district heating for certain countries. It's not um, um, uh, used over in all the countries in the world, but in some countries we can find this solution that is the solution district heating. So the final how to calculate the final energy for each energy form from the useful energy demand. So we will go for by form energy for energy form energy for we go for each for energy form. And this equation is available for space heating, water heating, and cooking. There where there is a competition with between energy forms, we will use always these equations where we introduce two parameters: the penetration rate and the efficiency. For district heating, the final demand is calculated by multiplying the useful demand by the penetration rate. Penetration rate for district penetration rate of the district heating, and we consider that the energy efficiency of district heating is 100%. For the solar thermal, it's the same. The final demand is the multiplication of the useful demand by the penetration of the solar thermal technology. For the traditional fuels, we multiply the useful demand by the penetration rate for the traditional fuels, and we divide this by the efficiency of the traditional fuel. And in the same way, we can calculate the final demand for the modern biomass, which is the useful demand for multiplied by the penetration rate of the modern biomass, and we divide this by the efficiency of modern biomass. And these equations are the same for the three uses: space heating, water heating, and cooking. To go further with the heat pumps, I show here the sample energy balance for heat pumps. Heat pumps, in fact, are an efficient solution to provide heat or steam. Heat, excuse me, that's for heat or water heated. This technology is high efficient, as I mentioned, and it transfers the heat from outside to the house. So it is more efficient than the other heating solutions. For example, here, this is the balance for heat pump. For 1 unit of electricity consumed, when having COP, coefficient of performance for example, here is equal to 2.7. When you consume 1 unit of electricity, for example, we will transfer COP minus 1, 1.7 units of ambient heat to the house, and we will have for 1 unit final energy consumption 2.7 units of useful energy, and is highly efficient. I introduced this because when we calculate the final energy, final electricity demand, we will use the part of energy provided by heat pumps, and the performance of the heat pumps, which is indicated by the coefficient of performance. And when there is no when we don't know use heat pumps, the final electricity demand is the useful demand multiplied by the penetration rate of the electricity. But when we use heat pumps, when we have heat pumps in the country, uh, there will be two parts of electricity consumption for heating. A part that is provided by other solutions of heating, and the part that is given by the heat pumps. And we should consider that heat pumps are have an efficiency that is for example, for one unit of a as I mentioned in the slide before, for one unit of electricity, for example, consumed the COP, and we have and when we have a COP of 2.7, the useful energy it will be 2.7, and we will consider this efficiency to calculate the final electricity demand when we have in the country heat pumps. And finally, for the fossil fuels, in the same way as for the other forms of energy, it's always the multiplication of the useful demand by the penetration rate, and it is divided by the efficiency of fossil fuels. But here there is just a fraction that it will be added to fossil fuels here, which is the fraction of solar thermal with backup system, as defined in MAED. This solar thermal system uses energy, solar energy, but when there is no solar energy, we will use fossil fuels to provide heat or to for cooking. So that for the total final consumption of the fossil fuels, we will take in account this part of the consumption which is used by the solar thermal solutions. For the air conditioning, as I mentioned before, the two forms of energy that are used for air conditioning, electricity and fossil fuels, and we will use always the same generic equation. The final energy consumption will be the useful demand multiplied by the penetration, and it is divided here by the efficiency. The efficiency will be for air conditioning the coefficient of performance of the air conditioning systems. This is the same for the electricity and for fossil fuels. For appliances and lighting, there is there the expressed in final energy. There is no energy efficiency parameter in the equation, but we will consider here the percentage of electrified dwelling, so that the final demand, for example, electricity, will be the total number of dwellings multiplied by the percentage of electrified dwellings, and this is multiplied by the specific electricity consumption per dwelling. And for fossil fuels, people who are not electrified will use fossil fuels, and that's why the final energy consumption for fossil fuels, it will be the total number of dwellings multiplied by 1 minus the percentage of electrified dwellings. This is the percentage, in fact, this is the percentage of not electrified dwellings, and we multiply that by the specific consumption of fossil fuels per household. Is there any question, or I can continue? Is it clear? Okay.
Yes, continue.
Yes. Okay, we will move now to the structure of the residential sector in MAED. So to define the structure, this is defined on the first sheet where there is the general information of the case study. And as we see here, there is two predefined subsectors, which are urban and rural households. But the user can define other types of households within each subsector, and this will depend on the information that is available. If there is no details about um, the types of households, we can just use the predefined subsectors. And as an example of types of households, we can divide households by, for example, the types, for example, villa, flats, semi-detached houses. We can have different definitions that are considered by the user. And for each type of household, we will select the from the main use of energy that are defined in MAED, the uses that are considered in this type of household. This is how to define the structure in MAED. And after the data about the household sector will be introduced in these sheets. And in the first line, we will have the percentage of dwelling types that were introduced in the first and the general information sheet. Here we will define the percentage of each type of dwelling in the first line in this table. So we can move now to the input data. So what we need for the household sector is the shares by type of dwelling, the average size of houses by type of dwelling. For water heating, we will need specific requirements per person in useful energy, the percentage of homes with water heating systems, the participation of energy sources within the useful energy, and the energy efficiency. For cooking, we need specific requirements for houses in useful energy, participation of energy sources within useful energy, and the energy efficiency. For heating, we need the heat losses rate per dwelling, the percentage of houses with heating, the participation of energy sources within useful energy, and energy efficiency. For air conditioning, we need specific requirements for houses in useful energy, the percentage of homes with air conditioning systems, and COP, the coefficient of performance. For specific uses of electricity and lighting, we need the electrification rate, the specific electricity requirements for equipment per dwelling, and the specific electricity requirements for lighting per dwelling. The urban and rural sectors are modeled the same, so the explanation given below are valid for all houses of the two subsections. The parameters here are the same for the different types of households that are defined in MAED, or that are the other sub section that are defined by the user. For example, the types are other types of that will be defined in each area. We will use the same parameters. So here I will here how to show you how to go from the data that is given in the energy balance to the final energy consumption by end use. And this is the data that we will need to calibrate the base here. So in the energy balance, we will have data for different energy forms that is not in the typical or the typical energy forms that are defined in MAED. After we will just aggregate, for example, this part will be fossil fuels, and this part will be heat for in MAED. And to have the final energy consumption by end use, even you have data that is coming from sensors or surveys, or we will make judgments. So we can distribute each energy form energy the consumption for each energy form through the different end uses. So, for example, here for electricity, we can assume that 10% is consumed for space heating, 5% is consumed for water heating, 10% is for cooking, etc. So the total is 100. And in that way, we can estimate the final energy consumption by end use. And to go further, to have the data that is splitted by household type, we can also, in the same way, make assumptions about the share by household type. And in that way, we will have the data, the final energy consumption by end use and by household type. So, as I mentioned before, how to here I will see the data, the input data in MAED, and how to um, estimate this data through the data available in the energy balance. For example, here is the data related to the water heating, and here in the first line we have the specific requirement for hot water per person. It is expressed in kilowatt hour per capita per year. So how to evaluate this using the data available in the energy balance? In the energy balance, we will find the consumption for water heating. As I mentioned before, we can have this data, so the assumption about the the part of energy consumed for this end use. And here we have the energy consumed for water heating by each farm. So we need information about the part of heat pumps that are used for water heating, and for solar thermal, as I mentioned before, there is a backup with fossil fuels, and we will need the information about this backup, this percentage, And having all this information and using the energy efficiency data for each form of energy, we can then be able to evaluate the useful energy consumption for water heating. Here, as presented in the presentation about the industrial sector, when we have competition between several yes, yes. When we have competition between several forms of energy, and we will use the energy efficiency parameter. This parameter will be adjusted according to the efficiency of electricity, because when MAED we consider that the efficiency of electricity is 100, but in reality it is less, and all the other efficiencies should be adjusted according to this assumptions about the efficiency of electricity in MAED. So in that way, we will have the useful energy consumption for for water heating by energy for, and the sum will be the total useful energy, and to calculate the specific requirements per person and useful energy, we will divide this total consumption by the people with a hot water system. And the people with a hot water system are in fact given by multiplying the total population by the percentage of households with hot water systems, and this is multiplied by the persons by household. For cooking, here the data needed for in MAED needed in MAED for cooking, and here is the specific requirement for cooking by per dwelling. So, in the same way as for the water heating, here is how to calculate the specific requirements per house, per dwelling for cooking. So we can start by the final energy consumption for cooking that is estimated or given by estimated as presented before. And we needed information about the use of heat pumps and the solar thermal share, the percentage of the backup with fossil fuels. And having this information and the data about efficiency by energy form, we will calculate the useful energy consumption for cooking for the different energy forms, and the total useful energy will be the sum of for all the energy forms. And finally, the specific requirement per household in useful energy would be this total useful energy divided by the number of households. For space heating, we have this. Here are the parameters that are needed for MAED for space heating. We'll focus now on the heat losses rate, this parameter. How to estimate this using the data available in the energy balance. So we have estimated the final energy consumption for heating for the different energy forms, And by having information about the heat pumps share and the backup with fossil fuels part and the energy efficiency information, we can estimate the useful energy consumption for heating for different energy forms, and we can, after aggregate all this energy consumption, to have the total useful energy consumption for space heating. And the heat losses rate will be this total useful energy consumption divided by the number of households multiplied by the households with heat, percentage of households with heat, and multiplied by the total area by household, multiplied by the percentage of area with heat, multiplied by the degree days. This is the parameter that was defined before, and this is multiplied by 24. This is how to calculate the heat losses rate using the data available um, and the energy balance. Here is the parameters that are used for air conditioning, the equipment rate, the specific requirements by households, and the implementation of energy forms, and the COP for electric AC and non-electric AC. So the number of houses with air conditioning will be the total number of households multiplied by the equipment rate or the percentage of the dwelling with air conditioning. The COP is the efficiency indicator, coefficient of performance, and to calculate the specific requirements per household and useful energy, we will divide the final energy consumptions for AC by the number of dwelling with air conditioning, and this is multiplied by the coefficient of performance. Here is how to calculate the specific requirements per household and useful energy. For appliances and lighting, here are the data needed for appliances and lighting. So we need the electrification percentage. This will use to estimate the number of electrified houses, the number of electrified houses will be the total number of houses multiplied by the percentage of electrified houses. And then to calculate the specific consumption of electricity per household, here there is no competition between energy forms, and the total we use the total final energy consumptions, and the specific consumptions will be the total final consumption divided by the number of households. And this is all for the residential sectors, modeling the equations, the structure, and the input data that the data that is needed to estimate the energy demand using MAED. Is there any question about the residential sector?
No question.
So we can move, I think we can move to the second presentation, which is about the service sector. I will stop sharing this. Start. I will Okay. I guess that is the second presentation is in now on the screen. Service sector. Is it okay?
Yes, Rashid.
Okay. Sorry. Okay. I have just an issue with my window. Just okay. So let's move. The content of the this presentation is in the same philosophy. In the same philosophy, the equations of the service sectors, the structure of the sector in MAED, and the input data. So calculations for the service sector are made taking into account combination of the different activities of the sector, the level of economic level of economic activity, GDP of each subsector, and services workforce. This is which will be used to calculate the floor area. And when the demand for and use can be met from different sources of energy, always the values are calculated in terms of usable energy, and the final energy demand for those end use is then calculated from energy efficiency and the penetration of the different energy forms. So typically, this is the structure of this service sector in MAED. So we can define the user can define different subsectors. Here we can, for example, for the service sector, we can have a commercial, public subsector, and the other that are aggregated in one other services are aggregated in another subsector. And the main uses of energy in the service sector are um, the specific uses of electricity, air conditioning, heating, other thermal uses, and motive power. The specific uses of electricity are provided, the energy used for specific use of electricity is 100% electricity. This is the energy form that is used exclusively for the specific use of electricity. For air conditioning, we can use either electricity or fossil fuels. And for heating and other thermal uses, we use either electricity, fossil fuels, traditional fuels, district heating, solar thermal, modern biomass or heat pumps, and motive power. The energy used for motor power is motor fuels. Two guiding parameters. We have two guiding parameters for the service sectors. As for the industrial sector, the energy demand will be correlated to the level of the activity. But the difference between industry and services, we have no material products, but services. But to give these services, we will need we cost energy, and the consumption, the energy consumed, it will be correlated to the level of the activity. But for air conditioning and heating, this is will depending on the total floor area, which is depending from the depending on the number of employee and the area occupied by each employee. We will this in the equations. We will see this in the equations after. So for the floor area, this parameter, how to calculate this parameter? The total floor area is the number of employees multiplied by the floor area occupied by an employee. And the number of employees, as we have seen in the first presentation, in the table about the demographic data, there is information about total potential labor force, sorry, active workforce and labor force in the service sector. This information will be used to calculate the number of employees in the service sector. So the number of employees in the service sector will be the total population multiplied by the potential labor force. This is a percentage multiplied by the active workforce, which is also a percentage from the potential labor force, and we multiply this by the part of this workforce that is used in the service sector. Here is how to calculate the total area that it will be used after to calculate the energy needed for space heating and for air conditioning. So the equation about how to calculate the useful energy demand for space heating or for air conditioning, the equations are quite similar. For space heating, for example, the useful energy demand is calculating by multiplying the floor area, total floor area, what we have seen before. We multiply this total floor area by the area requiring heat and the fraction of this area that is actually heated. And we multiply this by the specific requirements of requirements for heating. This is how to calculate the useful energy demand for space heating. For the air conditioning, it's quite similar. We multiply to have the useful energy demand. We multiply the total floor area by the area that need that need air conditioning, and this multiplied by the specific requirements for air conditioning. Just the difference is we have just one single parameter to calculate the fraction of the area that is that needs air conditioning. For air conditioning, we have just one parameter, and for heating, we have two parameters: the total area requiring heat and the fraction that is really or actually heated. For the air conditioning, we directly we will mention the area that is actually heated. For the other thermal the useful energy demand will be calculated using the generic equation that we have seen before. For example, for the industrial sector, the equation is the multiplication of the energy intensity by the value added or the GDP part of the subsector. And this is calculated for each subsector, and the total useful energy demand for thermal uses for the service sector will be the aggregation of the energy demand for the different subsectors. For the specific uses of electricity and motor fuels, we will use the same generic equation, so that for each subsector, the useful energy demand for specific electricity uses or motor fuels will be given by multiplying the energy intensity for specific use or for motor fuels by the GDP of the subsector, and the total useful energy demand will be the aggregation of this useful demand for the different subsectors. Now we will see how to go from the useful demand to the final energy demand, and this is the same as we have seen for the residential sector. For district heating, the final demand will be calculated by multiplying the useful demand by the penetration rate of the district heating, and we need not need here the efficiency because it's considered 100%. For traditional fuels, the final demand is the useful demand multiplied by the penetration rate of traditional fuels, and this is divided by the efficiency of traditional fuels. For the modern biomass, it's calculated in the same way. For the solar thermal, the final demand is the final demand is given by multiplying the useful demand by the penetration rate of solar thermal technology and multiplied by the share of solar thermal. And this is available for the two uses, heating, space heating, and the other thermal uses. For air conditioning, we'll use two forms of energy, electricity and fossil fuels, and the equation is the same. The final energy is calculated by multiplying the useful demand by the penetration rate, and this is divided by the efficiency. The efficiency is for air conditioning is the COP, the coefficient of performance. Now we will see the structure of the service sector in MAED. So the structure is defined in the first sheet which is about the general information. We will have one single subsector predefined in MAED, but the user can define different subsectors. It's according to the data available. If we have more details and we want to focus in our analysis on some subsectors, we can define subsectors in this sheet, and for each subsector we will select the energy uses that available in this subsector. The data after will be given through three sheets. There is a sheet about basic data and factors, a sheet about energy intensity, and a sheet about the penetration and efficiency. And here we can see we will have for in this sheet, which is about the energy density, much, as much as the number is of subsector defined first in the first sheet. When, for example, when having here 3 subsectors, here we will provide and we'll introduce in MAED the information about the energy intensity for the different subsectors that are that was defined before. The input data. Data what is needed. Data what is needed in MAED for the service sector is the labor force and the sector, the floor area per employee, the percentage of floor area that requires heating, the percentage of heated floor area, the specific energy requirements for heating, percentage of floor area with air conditioning, specific energy requirements for air conditioning, energy intensities for motor power, thermal uses, specific use of electricity, fuel efficiencies in thermal uses, participation of fuels in thermal uses. These are the data that is needed for the service sector. So this is was mentioned before, and for the data sector, for service sector, we can also have this technology that is used to provide heat for buildings in the service sector. So the same way that we have seen for the residential sector, here is how to calculate the final consumption by end use. Even we have the data that is given by surveys results, or we make judgments about the distribution of the consumption of each energy form, so the different uses of energy, and in that way we can calculate the final energy consumption by end use and by energy form. This data will be used after when calibrating the base year. So for the data that is introduced for the space heating is the labor force and service sector, the floor area per employee, the share of area requiring space heating, the area that is actually heated, and the specific energy requirements. Here we will see how to sorry, and also here other parameters that are needed for space heating, which are the penetration rates for different energy forms, and the efficiencies. Just this is this the definition of the how is the energy balance for heat pump. We have seen that in the previous presentation. So here I will show how to calculate the specific space heating requirements using the data given in the energy balance. So by having data about the space heating, the final energy consumption by energy form for space heating, this is given, as I mentioned, through surveys or through through judgment and using the energy statistics available in the energy balance. We have this data about the final energy consumption for space heating by energy form, and we will need the solar thermal share, and the information about the COP. And having this information, we'll also need the energy efficiency for the different energy forms. Energy efficiency, as I mentioned before, the adjusted one, according to the efficiency of electricity. And using this information, we can calculate the useful energy demand by energy form for space heating, and the total useful energy demand for space heating will be the aggregation of the useful energy demand by energy form. This is the total energy useful energy demand for space heating, and to calculate the specific space heating requirements, we divide this total useful space heating demand by the total area multiplied by the area requiring space heating multiplied by the area that is actually heated. And in that way, we will calculate the specific space heating requirement. Now we can move to the thermal uses. Here are the data needed for thermal uses. Here is the energy intensity for thermal uses for the different subsectors. And to estimate the energy intensity for thermal uses using the data available on the energy balance, we will need information about the solar thermal share and the efficiency, the adjusted efficiency, always the adjusted efficiency of the different energy forms. And using this information, we can then calculate the useful energy demand per energy form for thermal uses, and we will aggregate this data to have the total useful energy demand for thermal uses, and the energy intensity for thermal use will be the useful energy demand for thermal uses divided by the GDP of the sector. For air conditioning, the data that is needed, it's about the labor force and the service sector and the floor area per employee, the floor area with AC, and the specific cooling requirements. This is the data that was shown in the equations before. And the floor area with AC would be, as mentioned, the total labor force and service sector multiplied by the floor area per employee multiplied by the percentage of floor area with AC. And we will need COP, the coefficient of performance, and this information to calculate the specific requirements in useful energy for air conditioning. And this specific requirements will be the total final demand for cooling divided by the floor area with AC in square meter, and this will be multiplied by the COP, and this is how to calculate the specific requirements and useful energy for air conditioning in the service sector. For the motive power, what we will need is the energy intensity. And for the specific electricity is the same also. We need energy intensity. This information is to be introduced in this sheet, the sheet about the energy intensities. And the energy intensities are for these two uses are expressed in final energy demand. There is no competition between energy forms to provide energy for these uses. So the energy intensity for specific uses of electricity will be the energy demand for electricity specific uses. The final energy demand divided by the GDP of the sector, and for the motive power, this the energy intensity will be the final motive final demand for motor fuels consumptions divided by the GDP of the sector. And this is all for the service sector and for the two sectors for today, the residential and the service sectors. I hope that it was clear what is the structure, what is the equations, and how to what are the data that is needed in MAED to evaluate the energy demand.
Yes, thank you. The presentation. Thank you for the presentation. A lot of information, of course, for a day. I wanted to find out, how do we deal with the specifics, like on the end use, space heating, air conditioning? I was noticing some of those things, and how do they apply? Because there are some things that are really not applicable in some of our situations. So how do we deal with certain things? I'm not sure if I've asked the right question or if you understand it.
Yeah. Okay. Yes. Thank you, Mrs. Shewett. Yes. Actually, in the model is so flexible. Don't have space heating. Example, in your case, you just select the button. So you saw in the general sheet where Rached was presenting the structure of the model. When you are structuring your model, if you don't check the box corresponding to space heating, then you will not have to provide data for space heating. And that is, it is possible. In some country, you don't even have the need of space heating. The temperature over the whole year is warmer enough for people to survive. So in many cases, you may not even use the space heating. You just need to uncheck the button, and then you will not have to fill in those data.
Thank you.
I don't know if it is.
Okay, that's clear. Good. Thank you so much.
Thanks.
I see another comment in the chat. It's about the definition of the subsectors. Yes, what was presented is just an example about the some subsectors that we can define for the service sector. But if there are more details, if we have data detailed about the service sector, we can define much more subsectors. And it's depending also on the what we are aiming in for our analysis. The best will be to have something that is more simple and more accurate, I think. But if there is more more details, and we want to focus on some subsectors, this is possible to define more subsectors in the service sectors. Is it clear, Hassan? You can define as much as you want, but this is depending on the data available and what you want by the model to analyze. What is the aim of the study? Yeah.
Good.
Yeah, the main thing is
it was also.
Yeah. Okay, go ahead,
Okay.
Manu. The main thing is that you have information of both, you know, GDP and the energy consumption. And this to have it for the service sector is very subsectors, it's very complex, you know. So service sector is very vast sector, as it was explained by Rached. No, it involves hotels, schools, hospitals, governmental buildings. So it's it's really in many countries, even in many developed countries, this sector remains, how to say, very scarce in data. Yeah. So to have this consistency between what is reported in your country in terms of GDP, what that subsector provides, and how much energy it consumes, sometimes it's really difficult to find this whole information for this sector. Yeah. So that's why this is the only sector where most of our, let's say, services are just being aggregated into one. Yeah. So just because of this lack of data.
Yes, Peter.
Yeah, this is Peter from Kenya. I just want to find out whether the model tool is versatile to enable one to maybe to input what, I mean, maybe an additional item, or you only work with what you are given. For example, maybe some parts of Africa, you don't need cooling. I mean, heating, but you need cooling. Are you able to switch or add an item, or you only work with what you are given? Thank you.
Yes, actually, for the specific case that you pointed out, it is in the model. That means it's one of the end-use category that is predefined in the model. We have space heating, cooking, we have cooling, we have hot water that is for household, we have also appliances, we have light. So you can only select inside this category. Yes. Of course, you can also use some tricks to introduce something. Let's say, for example, you may say that, okay, I would like to model the cooling, but by using the formula of heating. Then that is your own customization of the model. Yes.